Hi, Mr. Richmond. This is your Unit 9.1 lesson summary. Unit 9.1 will be on the least squares regression. It's our first section in Chapter 9. This is revisiting a section that we've already done in the book in Chapter 3 on linear regression. We're going to go to it again as we go in a little deeper in our study of regression equations in Chapter 9, and we'll see a couple new vocabulary words. The first new one is interpolation. That is when you're using a linear regression equation to make predictions within a data set. So what that means is, we've done this before, we'll show you again. We're going to find a linear regression equation using our calculator that can be used to make predictions about what the data is doing now and possibly doing in the future based on what we have here in our table. Well, when I use the equation to make a prediction within the table, which means I'm going to input values for x that are between 1 and 6. They're within my table. Then I'm doing interpolation. When I then try to use that linear regression equation to make predictions outside of the data set, so in other words, I want to start to look into the future where I don't know any data values, say 10 months, 11 months, 12 months, then I'm doing extrapolation. I'm looking for answers outside of it. Later on in this chapter, we will look at the predictions we get from our equation and compare it to the actual data values we have to make some analysis of how accurate our equation actually is. And that's kind of what we're going to focus on. So for now, let's just review real quick how to find a linear regression equation, as well as how to make a scatter plot, and just do a few of the other skills that we've learned with this. So to enter data, I press stat. I press stat and then edit. And I'll enter my data into L1, L2. I'll try to show that real quick. So I pressed stat and then edit. And then I have L1, L2. And I'll enter my input data. Time is my input data in the L1 column. And then I will enter my output data, which would be charms, in my second column. And so now I have my data entered. From here, to do a linear regression, I press stat, calc, scroll down to 4, and choose linear regression. From here, I press enter. And now I have my equation for my line of best fit. It says y equals ax plus b. I can now plug in what a is and what b is, and round however a problem tells you, or whatever you think is suitable for that particular problem. So let's put that down. So enter data we have to do a linear regression. I press stat, right arrow, choose linreg, and then press enter twice. Now, the problem that I have right now currently is I don't actually know if this data should be a linear regression yet. So I should look at the scatter plot before I do this. Since I've already pulled it up, I'm going to write that equation for now, but then we'll take a look at the scatter plot and make sure it should be a linear regression. So plug it into ax plus b form, it would be y equals 3.97x minus 2.0, let's round to 7. Okay, so this would be my linear regression equation if it fits. Now, to look at the scatter plot of this, I already have the data entered, so I just want to go to y equals and make sure plot 1 is highlighted, and then second y equals to make sure I have the right plots here. Since we've made box and whisker plots now, and some other ones you might run into different charts being selected. You want the top left one, the scatter plot. Then I can hit graph, and you're likely not going to see your graph because your window is not set. So whenever you're dealing with statistics, the easiest way to adjust your window is to press zoom and go down to stat, which will be the 9th one, zoom stat. Press enter, and now I get a good feel of my data. Now we'll draw a quick picture of that. And as I look at that data, it does look to me like it's rather linear, and that I might want to use a linear line of best fit. So if I was doing that, it might look something like this. And what my calculator is doing for me is doing a regression equation, comparing all these points, finding the distances between them, and trying to find a line that will minimize the distance each of those points is away from a best fit line. And this is the equation my calculator came up with. Now in the book, they do show you the full formula on how to find a least squares regression equation. It's a doozy, it's a long one, it's not particularly difficult if you break it down into parts, but I don't know if the requirement will be for you to do that by hand, because we have the technology nowadays. We want you to use that, but we want you to appreciate the equation. So make sure you look at the book and see that formula and have an idea of just how much is really involved in doing something like this. Okay, so it is a linear regression. I have my linear regression equation. Here, I'll show you how to put that on your scatter plot as well, just so we can make sure we have the correct regression equation. So I can also graph a line by pressing y equals and entering my line. And I'm going to go ahead and type in my regression equation line, 3.97x minus 2.07, and then hit graph. And just like that now, I can see my regression equation, my line of best fit through my data points, and it looks pretty similar to the one I drew on the board just by hand. Okay? Now I can use that equation to make some predictions. So the first prediction I'm going to make is predict the charms sold in the 4th month. So to make my prediction, I plug in 4 for the number of months, and I simplify this expression down. So I will do 3.97 times 4, which is 15.88, subtract out 2.07, and get 13.81. So that's my prediction. Now I'd like to kind of compare it to the actual value we had in the table. So when it was 4 months, the actual value in the table was 12. And so I can start to now look at that and do a bit of a comparison of how accurate my prediction is. It's pretty close. It's only 1.81 off. But it lets you see that your your regression equation is only going to predict. It's not really going to get that exact value that it is. Okay? Since I used 4 as my input, that's what I predicted for, this would be called doing interpolation, because I looked for a value within my data set that I already had. So this would be an example of using interpolation. And the next one, I'm going to predict the charms sold in the 8th month. To do that, I plug in 8 for x, simplify down, which is 31.76, subtract out 2.07, and I get 29.69 as my prediction. And if I look back at the table, I have no actual value to compare that to. And whenever you don't have an actual value to compare to, it's a good sign you're doing extrapolation, because there's no data yet for that. And extrapolation is usually the true reason why we're developing this equation. We don't really need it as much to do interpolation, because we know the data. This has already happened. We know the info here. We want to look at the past history of data and use it to come up with a model, an equation that can predict what might happen in the future. So if I had a city and I want to see how it's growing, I can look at previous data, previous years, to see how the city is growing, hopefully develop an equation and make a prediction of how big the city might be populated in 10 years. So I know what I need to start building. I can start putting in roads, sewage, things like that, and develop my city at the right pace. There's all kinds of uses for this. So hopefully that helps you out. Really, the big vocabulary terms are interpolation and extrapolation. And while we're on it, I'll show you what was left over on my board from a lesson we did in class for this. Because you might need the review, but it's going to be big that you know slope-intercept form for this chapter, which again was y equals mx plus b, where m is the slope, b is the y-intercept. You're going to need to know the slope formula. If you're looking at a graph, you can use rise over run to calculate the slope. If you do not have a graph and you're dealing with just coordinates, then it's real important that you can use this equation still, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What you will be doing with all this is taking 2 points and trying to write the equation of a line passing through them. So I just left an example on the board for you. I had the coordinates 1, 3, 5, 7 to start. And if I want to write an equation of a line, I'm going to need these two pieces of information, slope and y-intercept. So I start by finding the slope, because I have a formula for that, and I plugged in what y2 and y1 would be, and what x2 and x1 would be. And your first coordinate is your 1s, so that's why it's x sub 1, y sub 1. It's my first point. And my second point was x2, y2. I plug them in, I simplify the arithmetic, and I get the slope of 1. So now I know the slope of this line. And since I know the slope of the line, I can actually plug that in for m in the y equals mx plus b form. Okay? But now I'm trying to find a y-intercept b. And the only way I'm going to be able to solve for that is if all these other variables are plugged in for. I can't have more than one variable in an equation to solve it. So what I do is I temporarily take what x and y are from one of the points and I plug them in. So for here I plugged y in for x, 3 in for y, simplified it down and found that b was 2. Now just to show you, you can do that with the other point. I could use 5 and 7 for x and y instead, the 1 for the slope, and I use the arrows to show you where I'm plugging in. Simplify it down and I get b is 2. So either way, whichever point you decide to use, it'll work as long as you plug x in for x and y in for y. Now that I have the b and I have the m, I can start over by plugging it into y equals mx plus b form. 1 is the slope, goes in front of the x, 2 is the y-intercept, and that becomes my y-intercept, and I have my equation of a line that would pass through these 2 points. Okay, and just to summarize the steps for that process, you first find the slope m, then you plug m, x, and y from the coordinates into y equals mx plus b. You solve that for b, and then you can rewrite the equation in slope-intercept form. In my class, we kind of started with this. We knew this is what we wanted, and so we put some blanks in the spots that we needed to kind of give us an idea of the 2 things we're looking for. So I have to find the x, my slope, using my slope formula. After I've done that, I need to find what goes in this position, the y-intercept, by plugging all my info in and solving for b. So hopefully that'll help you out if you run into any of those problems in the chapter. You can also use point-slope form if you know it. That's a common way I like to do it. But for this chapter, I thought I'd show it a little bit different way using slope-intercept form, and maybe we'll visit how to use point-slope form to do this in a little later section. Thank you, and good luck.